Okay, here we go and welcome in. This is Design 300. It's our lecture for Tuesday, September 14th, and we are online. So, what I want to do today is go over foundations and footings, um, and we'll really also talk next week maybe about some stem walls. Then we'll get into floorings and slabs. But we're gonna really go into foundations and footings. And this week it's really concrete and how the concrete attaches to the soil. So let's take a look at what we're doing. We're doing foundations and footings this week. This is week 4. We're going to talk about concrete. And again, I'm going to have you do some annotations in Revit. The more you've touched Revit before you have to really use it, the better it is. It's a big, complex program, and it's number one in the construction industry. So we want people touching it as much as we can so that they can get familiar just at least with the interface before you actually have to do something with it. So we're going to again be doing some annotations focused on some new types of views called section views and callouts. So I'll be posting the recording of this lecture shortly. You do have a playlist. I've got it up over here, and it's all about concrete and concrete strength. And then when you look at this sieve analysis, it doesn't really explain why you're doing it, but you're doing a sieve analysis to make sure that the aggregate is the right size to get the strength that you're interested in. So the ingredients are water, aggregate, and cement. Those three things make up concrete. Lots of things affect the strength. And so this sieve analysis is one way to find out if your aggregate is proper and appropriate. And there are actually concrete engineers and structural engineers that have spent their whole life figuring all this stuff out and knowing all about it. We don't need to know that much right now. This slump test, these slump cones are for a slump test that tell you if your mix seems right. It's got the right amount of water in it. And if between the slump test and the sieve analysis, you can pretty much be sure that your concrete is the way it was meant to be when you're pouring it. Because when concrete first gets mixed, it's liquid, it's a slurry, which means it's schloopy, gloopy mixture of stuff. But if it's too wet, it has problems. And if it's too dry, it has problems and it won't work. So this slump test is designed to get it just right. This is just a fun one to show somebody doing a concrete pour. This one I absolutely love. If we were doing this face to face, we would actually go do this test because it's fun. But that's why concrete needs reinforcement. And so you'll get the first little bit of the idea of what rebar is for. And then I said we were going to be talking about footings. So this is about footings. And I think this Revit training actually gives you kind of the idea pretty well. We've had some issues with some students logging into Minecraft. They seem to not be showing up on the login list. So here's a little video. If you do exactly what it shows in this video and it kicks you back an error, please let me know. I've got a request in to our IT department to make sure that everybody's password is reset and all that kind of stuff. It's really a Microsoft issue. Microsoft has a secondary file of everybody here, and so that can cause some issues if that cross-linking file gets mixed up somehow, and our IT department can fix it. So that's what's on our playlist for this week. Let's see, what else do we have? We have a reading list, which is a Google slide presentation. That's right here. And this it's what it's the same one since 2017. Concrete doesn't change much, at least not in the main portion of the construction industry that we're talking about. There are incredible advances being made right now to increase the strength while reducing the amount of aggregate and water and cement that is used. That is truly the only way to work towards sustainability in my mind. I read this in a very cool sustainability book by a sustainability architect from San Francisco. And she said, everything we do is cool. We always want to drive to be more sustainable, but the one way to really do it is just use less stuff. And so there's been a lot of work in concrete over the last couple of decades to use less stuff. There's foamed concrete, there's highly analyzed concrete structures, there's different types of rebar, there's different manufacturing methods now to make concrete so that it can withstand the loads by using less stuff. But overall, what you're going to see in this is just the good old plain Jane concrete. So here we go. Concrete, what is it? I'm going to briefly go over this, and then you're going to look at these, and these are all sort of in there. Okay. But concrete is aggregate. That's a bunch of rocks and sand and stones. And you mix it together with dry Portland cement. Portland was the name of the guy who invented the system. It's not the place up in Oregon. So Portland cement. And it was pretty cool. It was one of the things that's very, very toxic to make. It's very, very toxic, even in its dry form. But once it's mixed with water and cured, it's totally, totally safe. So they have what they call death valleys where they make Portland cement. But one of the things that they did that was good is for many, many years, it comes out of the steel industry with the waste ash and the aluminum industry. So the waste product of the steel manufacturing process can be used as one of the primary components of Portland cement. So that's a good thing, but transporting it is horrible. Using it is horrible. It's a huge, huge carbon creator. So many people think that even though concrete has many, many good sustainability features, that because it's used so much and Portland cement is so bad for the environment that maybe it's not quite that good. Anyway, you mix those three things, aggregate, cement, and water. It gets all sloopy, mushy, slushy. You can look up what a slurry is. And you pour it into a mold. Now, sometimes the mold is just dirt. Sometimes the mold is dirt plus a form. And sometimes it's pre-poured concrete and a form. And sometimes, if it's a tall concrete building, it's a form. But there's something that makes that slushy, mushy stuff hold its shape. It has to stay as a slurry. If it separates, it's a problem. And so there's a lot to getting your slurry correct so that when you pour it into the form, um, it is homogeneous, and it's pretty good, and it takes often a matter of hours to a day for it to get strong enough, cure, become stone like enough, and that's just a chemical reaction between water and cement. Okay, and the cement coats the aggregate and holds everything together. And it'll take about a day to get to strong enough to remove the forms. Maybe sometimes they wait 2 days or three. And then you like to be able to remove the forms so that they are reusable. Okay, so this piece of uh, CSX or particle ply, you take these braces off and pull these off and just pull that out, and then that will keep its shape. That's the idea. Now, so you pour it in here. I mean, we don't do this around here. We don't have this kind of wood to be able to form like this. We form a combination of this. These little ties hold these things together. You pour that concrete in there and it wants to shove everything apart. And of course, as you get taller and taller and taller, there's more load. So usually there are tie bars in between. But here there's no tie bars. You just brace it. That's often done too. And this is called pour in place. In other words, you're pouring it where it's going to be used. If you're doing tilt up, it's a little bit different. And if you're doing it in a manufactured facility, it's a little bit different. Okay, so that's kind of concrete. There's aggregate. Let's take a look. You should be able to see about aggregates. So here's a whole bunch of cool information about the types of aggregates that are used, and there's different sizes of each of these types of aggregate, and you want to get just the right mixture of sizes and shapes to make your aggregate. And the structural engineer or the concrete engineer will be the one that looks all that up in the tables for the strength you need and the pourability and the transportability that you need and the cure time. And they'll put like a whole bunch of factors together and say this is exactly what you want. Okay, so these are forms, and you pour the concrete in there. Forms have to be pretty good. You can see right up here, there's some little, it's hard to see, but there's some strings. Those are leveling lines. And so they level you and get you lined up properly. And there's some skill to doing this. If you think that you just go out there and hire anybody to do the forming work, you're mistaken. This is highly skilled labor to be able to do this well and quickly and efficiently and right, so that your foundation, your stem wall, is level, it's even, it's got the anchor bolts, it's strong enough, you can seal against it. It really all has to be right. And people say, if you build a house on a bad foundation, it'll fall. And that is so true. So your foundation really is key. It's what transfers the load to the soil, and it's got to be done right. So there's another thing besides just mixing it. There's your size distribution, and you can just look these things up. Okay, the idea is I'm not giving you everything now, but now I'm giving you keywords, and you should go and just type that in to Google and look it up and just get some information about it. I think there'll be more. Nope, that's all we've got on. So you can go look those things up. Okay, and we just talked about pour in place. That's what we're talking about here. Okay, look how much concrete is used. Okay, ton for ton, concrete is used more than steel, wood, plastics, and aluminum combined. That's a lot of concrete, and it's actually causing environmental problems now. Even 30, 40 years ago, it was considered that sand and aggregate and bauxite and the things that made up concrete were so plentiful that we would never run out. And that's just not the case. There's sand pirates now, and we're totally denuding huge stretches of rivers and lakes and oceanfront of sand. So there are some problems with this, and it's good to know about. The good thing is that, as you can see from the aggregate, do I still have it up? No. From the aggregate, you can see that one of the biggest uses of concrete is recycled concrete. And if you're familiar with the work that was done on Highway 80 between Natomas and American River College a number of years ago, it was 3 or 4 or 5 years ago, they actually recycled the concrete of the existing I-80 roadway to be the primary product, the primary aggregate. And they had big ball mills out there and stuff like that. So it was kind of cool. So that's what we've got there for you to look at. Now we're going to talk about foundations and slabs. And they're two different things, but sometimes they're the same. Sometimes your foundation can be a slab. Okay, and so this tells you about it. It's what connects the structure to the ground. And so in this case, there's a stem wall that's connected to the ground. Okay, and there's a footing. The footing takes all the load in the vertical direction. Okay, so as my force sits on top of it, it pushes down and pushes down. And now here's one that's showing it as a slab that you can put on there to make a floor, a raised floor or something like that. Or it's really kind of two drawings in one. This upper one is slab on grade. This lower one, you see there's a footing down below. Okay, and all the load goes down into the footing. And then to get up to the proper level where you want your floor system, it's something called a stem wall or structural wall. And underneath that is a footing. Okay, and there's a really cool little YouTube about how you can do that in Revit. And so Revit really is set up to be a architect's and a construction manager's friend. So you can draw your wall and then say put a footing on it. And that's really, really, really cool. And then there are other things that we can talk about. We'll do later. And here's a slab on grade. This talks about slab on grade in here. Okay, so this is just stuff to look at. The main thing that you need to know is that in the United States, you've got mostly footings and stem walls made out of concrete. And sometimes this footing will go all the way around, as you see in this. It'll go all the way around. And sometimes they'll just be pier with a post. It's called post and pier, where they're just little square blocks spread out around here to take the load of the floor. We'll talk about that more in just a minute. Okay, so that's where your reading is going to go for this week. Let me come back into here. There are a couple of discussions for you to do this week. So this is a really nice detail. It's kind of a how-to, and it doesn't tell you exact. It doesn't tell you that this is a certain strength concrete with a certain pour. It tells you that there's anchor bolts, but not how far apart they are, or how big they are, or how they're locked into place. It just gives you some ideas. And now here's a really cool thing that many people don't think about, but sometimes a footing is poured or placed. Sometimes these footings are pre-poured, and then you're gonna pour the stem wall in place, and you might look at this and go, huh, I see a little groove here, and I wonder what that's all about. I don't know what that is about, and I'm not sure what a spacer tie is for. And I kind of get this block and stake, but I'm not positive what all these things are for. And what's a whale? What is that thing? And so this is really telling somebody how to form some sort of a foundation where there's a footing and a stem wall. And it shows that this is dug back a certain distance. It doesn't tell you exactly how far. So it's just kind of interesting. So there's jargon on here. This actually came from a building code in Michigan. And inspectors will take drawings like this out and just make sure that things are properly done in accord with this. So here's what you'll do. You'll review it. You'll identify a few things that you don't know what they are and make a quick thing. And you might make a Jamboard to show this on. So let me show you how to do that. I'm going to take a snip. So there's a snip of it. And I can open something called a Jamboard. Let me see if I can get into where my Jamboards are. Jamboard. So if I just start a new Jamboard, I can pop that on there just really quickly, and then I can make it bigger if I want. But then as I'm doing my video, I can use this little tool down here to highlight things like an anchor bolt. I see what it is, and I think I know, but I'm not really sure. I'm not really sure what a whale is or what it's there for. And I'm not really sure why all this bracing needs to be there and how far up you put it, and the bottom blocking, why is that there? And so, these are really interesting questions. Why is this piece here? Why are these pieces here instead of just putting your horizontal brace right up onto this? What do these spacer ties do and things like that? So it's nice to be able to use Jamboard or some other tool where you got a little laser tool, and then you can even type up your questions even ahead of time, and it makes your presentation easier to do, and then you can just point at them as you go. Okay, so this is a way to prepare for doing verbal presentations. So it's a good, I'm slowly working towards doing things like this. So if you'd like to use a Jamboard when you do your thing, that's really good, because then you can point at things and it helps you speak clearly about what you want to do. Okay, so let's come back to here. And workplace preparedness, again, we've got another one. Here's a structural drafter that I pulled up. I just used another one because we're doing structural. Okay, 20 to 30 an hour. That's not bad, especially for Sacramento. 20 to 30 an hour if you had to live in the Bay Area is probably not that great, but if you could get in the Sacramento office, and what we've found is when we see ones like this where they offer both, often they'll ask you to go to the Bay Area office for 4 to 6 months and then transfer you, and they give you a stipend because they know either a travel stipend or a living stipend to live in that area before you come back to Sacramento as trained. Okay, but what do we want you to do? Look at the job posting. Look at the description of the job that's up here. Okay, and then just tell me, do you understand what this job entails? What do you and don't you know? You might go, huh? What is? I don't know what MEP is. Um, what I get an idea, but what does it mean to prep construction documents for design review? I don't really know what that is. What are red lines? We've talked about those a little bit. So you might have some of these things that you don't know what they are, and it would be hard to go into this interview without knowing what those are. So I'm not interested just in this. I know you know what AutoCAD is, and now you're getting some Revit. But look at these things up here. Okay. So then we've got two sets of calculations to do. The first one is about, this is the second one. The first one is about how do people design these footings with stem walls. So this stem wall has to carry a load. Okay, so I say it's going to carry some sort of a load. There are your loads. And I say that load is going to be over some length. Here, 114 feet. So the trick then is to convert that, and I'm going to make this bigger so you can see, is to convert that feet into inches. Because we always work in PSI, pounds per square inch. So inches. So what is that? That's going to equal your feet times 12, right? That's how you get to inches. And then, of course, you can copy it down. And then what's my building load in pounds per every inch? So if I have 87,000 pounds and 1,360, it's pounds per inch. Per means divide. So it equals pounds per, that's divide, for every inch. 63 pounds for every inch of this. I can already tell that's getting pretty light. And so now my footing width, okay, my pressure on the soil. Remember we started talking about pressure on the soil. And that's pounds per square inch. Well, every inch that's cut off of here is going to be spread over an additional 12 inches here. So my pressure on the soil is going to be 63 pounds per inch divided by my footing. And I'm down at 5 psi for my soil. Okay? And then that's the geotechnical person. That's what we did last week. We said, oh, I wonder what number my soil can carry. So depending on the Proctor test and the building pad and how it's compacted and everything, the architect or the structural engineer is going to design this. Now, what's really cool is, let's say somebody said, oh, my soil can only carry 4 pounds per square inch. Excel is really great because I can just make that 16 and 3.9. I can just change it right off the bat. Oh, I like that. That's really good. So you can change this number very easily to get your answer that you're looking for over here. This is how these things are used. So I've got a soil limit that my geotech gave me, and I'm going to just check my design. I've done my building design now, and I found out my load of the building and how much it's going to carry over, and I just calculate on through to figure out my soil. How hard is this going to push onto the soil? And if that number is smaller than what the soil can handle, I'm good. Yippee-yi-yo-ki-yay. That's how we do that. So you'll go and do that for all of these, but that was the calculation, right? Okay, it's building load divided by the inches that it's spread over. Pounds per inch. Pounds for every inch. Pounds spread over an inch. That gives me that. Building loads, pounds per inch. And then if I do one more and get one more direction, then I've got an area. It's a pounds per square inch. PSI. That's how you do that calculation. You just need to run a couple of those through. My next calculation, and this came from actual data. Okay, when we do this class live, I go in and I bust stuff. And I may go in there and take some images for you. So here we ran 11 samples. There were 11 people in the class, and they each got a chunk of concrete. It was actually cinder block that was about 2-inch in diameter, 3 inches long, and we crushed it under a big hydraulic press, and we read the load that it broke at. So we want to see how strong that concrete is. So first I have to find out what is the area. Area of a circle is 3.1.4 equals 3.141 times the diameter. It's written there. Times the diameter again, divided by 4. Pi d squared over 4. Those are all going to be the same. And pounds per square inch. Well, per means divide by. Equals pounds spread over divided by 3.550 pounds per square inch. So that's how much that cheapo cinder block could hold. And we have a whole bunch of them. And later on, we'll look at this and talk about averages and max and min and all that kind of stuff. There you go. Now, you look at that, you can see concrete, 1 square inch of concrete is way stronger than that square inch of soil. So we're spreading out and using all this concrete to spread the load out over the soil. So that's how you'll do this one. Okay. Here's the calculation right there. There's the calculation right there. Okay, and we're running through things pretty well. So now I know that some people had difficulties logging into Minecraft. Please just send me your W number if it was not accepting it, but be sure that you've watched this tutorial and done it exactly like I showed. Because then we know, okay, you did all the steps right, and we can go check to see what's up with your login name. But if you did this one, now you're going to make this one, which is how to make a portfolio PDF in Minecraft. So you're gonna go through here and create this portfolio thing. Okay. And so I'll want to see your exported portfolio that you were able to make. Okay. And look, if you're just still trying to get on and get this, I'll take some points off for now that you can either choose to go back and do or not do. But if you need to resubmit to get some points, if you weren't able to get into it, that's good. But this is driving towards a major project, and I'm trying to get you all into Minecraft, used to Minecraft, able to use Minecraft. Excuse me. Before we have to do the technical part of the project. Okay, so this is what you're up for this time, is the portfolio. And then that takes us to the submittal template to look at. So again, I'm just going over what's due. So now be sure I've marked up just about everybody who missed doing these ones. Next week or this week, if these are not done, if this is not turned green and this does not have a link, then you will not get full credit here. Okay, so everything needs to be filled out. Now, a few little comments that I'm still going to go over. Please avoid lining an image right up on the edge. Always leave a tiny little bit of bleed around your images. Okay. Also, avoid putting an image over this stuff on this page. Okay, you can delete this if you want, but this is telling people what they should be seeing here. And so try to get your stuff arranged on there in that fashion. Again, here's your materials studied and links. And if you only have a few that you need to do, you can resize. Okay. And these, please, a few people are still putting text in here, a lot of text. I want annotated images. So that's an image with a little annotation, a caption, a title, a short description on the image so that I can tell what it was that you were talking about. Okay, so those go here. Now there's just two of them. These, you can either just fill in the data or replace it with your own. Okay, and then here's your two drawings you're going to do. And I'm going to talk about those drawings next. I'll demonstrate the Revit next time. And a few people, and here's your Minecraft one. So this is where you're going to post your images from your portfolio. And I don't just want snips out of this. I want you in there doing it, if at all possible, if you can get in there. Same with this. A couple of you did some really nice presentations, and then some people took snips out of this, and I don't want to see these snips. I want to see you actually do these. Okay, because those are skills that are helping us know that you're ready to do our project, which comes up in week 10, 8, 9, or 10. So I'm really easing you into it on these. Okay. And then somebody said, well, what do I do on this last one? Nothing. There's no points, no nothing. This is for your information that just tells you how I'm going to grade it. Okay. And so, I look at technical content, visual clarity, professionalism, and full understanding. So I kind of look at all those, and if this mostly applies all the way across the board, you're going to get a full. If it mostly applies and one of them really doesn't, you may get half credit for that page. Or if it's just kind of like, yeah, it's there, it's good, but I'm giving you half credit for that page. And then if you really didn't demonstrate it, you get none. So I try to put the grading rubric in each one so you don't have to search around for it. Sometimes I'll forget it, and you can know that it is on the homepage. Okay, so that is kind of the overview, or you can get it right here. That's the overview of what's up for this week. There's not that much. I mean, we're just kind of cruising along. So I want to go to our resource files and start talking about these. Okay. And we're going to really this week be talking about foundations. And those are two types. And I'm going to show those two types in here. And let me see if I can make that a little bigger. There we go. So this is a section as it comes out of Revit. So it's really cool. I just built this building and there it is. That's cool. So you can see my roof structure. That's sort of showing that there's some sort of truss or rafter or some sort of thing going on here. But that's the shape of my roof. In this section, I've cut my building and I'm looking at just what got cut. Okay, and there's some sort of a wall, and the wall sits on a floor, and all that weight transfers through the wall into the floor, and anything that's sitting on the floor, the weight transfers into the floor and passes through to the foundation. Now you can imagine that if there was something here in the middle and this was a big long span, that could get pretty saggy and baggy. So at regular intervals, I put down what's called a pier block and a post. The pier block is concrete and it just sits on the ground. And the post is wood usually. And believe it or not, you just put in a post and then you put shims in often to just sort of connect the joist or the floor system onto that. So this long 2x6, 2x8, 2x10, whatever it happens to be, maybe it's a joist or a truss, they just sit on these. And the architect or the structural engineer tells you how far apart they have to go and how far apart in and out of the page they have to go to support this floor. But then all the loads go into these things and all the roof and everything goes into this. And so you can see these all sit on the building pad. And sometimes the building pad is above the ground, and sometimes it's below the ground. If it was below the ground, then you have a footing and a stem wall. If it was above the ground, usually it's just a footing or just a stem wall. Okay? And this dirt presses sideways. But this is usually strong enough to withhold the dirt if it's not too deep. So that's what this drawing is showing you. Concrete footing, and its width is set so that all this load transfers to the ground without damage to the ground. And these are sized as squares or cylinders so that they transfer the weight to the ground. And the stem wall is basically just so you can get up above ground, because in most parts of the country, you want to avoid water and pest damage to your floor system and your walls. And to do that, it'll usually be 6 inches from the ground to your floor system. Now, some places, because of flooding and water and stuff like that, these just transfer right on across, and these are pure blocks also. But around here in the valley, you're going to see it like this. Okay? So that's a section view. Now you see something here that's got a bubble on it and a little kind of thing around. That's called a call out. Because on your piece of paper, this is going to be pretty small, and it's just for some general notes. And then this call out will have a bigger view all of its own. So here it is as a call out, and now it's getting a little bit more interesting where we're calling out, okay, what are some of the elevations? What are these places called? What's actually in there? Here we've showed that we have backfilled to a certain depth for the footing. Okay, so you would have had to have made a trench and done all this out and poured the footing and probably formed this, and then you would do what's called backfilling once it's cured, where you fill all this back up with dirt. So this is showing it in a little bit more detail, and we're going to add a couple of little annotations to it. And now you can see that this is really showing itself. This is some sort of wood system with a layer of some sort of sheathing and another layer of the sheathing, and the wall sits right on top of that. And there's probably anchor bolts, and it doesn't really say how the sill is done or how this is connected. It could be through anchor bolts or plates or something. So there would be a detail about that. And look, this is showing that there's some sort of siding that comes right down to that floor system. And tell you the truth, I would suspect that this overlaps by 3 or 4 inches. Okay, so but this is a good general call out, and we would start calling out things about it. We would start calling out something about the concrete, or something about this size, or something about the spacing of these joists, or something about these two. So those are the two things that you'll be looking at, and you have here the foundations that you can go to. You can, there's your Revit file that we'll be working with. So there we go. That is this week. In our meeting on Thursday, I will go through how to do those drawings. Okay, I'll go through how to do the drawings that are required, and I should actually really put those in here, that those are required. It says to do them here. I think I'll go back and put them into here to be more clear. And there we go. You're learning about foundations and footings with a focus on concrete and how concrete is made, what it's made out of, how we test it beforehand, when we test it, where we test it, and look at it with respect to testing and Revit. Okay, so there we go. I'm going to stop the recording, and I'll post this shortly.